short tutorial on how to use NodeOSC. NodeOSC is a Blender add-on that allows you to send open sound control messages to Blender and control properties remotely. This tutorial will be a three-part tutorial. In the first part, this part will cover the basics on how to set up the server and create your own custom messages to control properties inside Blender. Second part is focusing on animation nodes, and the third part on Sorka nodes. Here on the GitHub repository you can find the latest releases and a wiki with some in-depth information for the settings. So let's get started with Blender. You see here the basic setup. I already installed the plugin. We have here some general preferences. There is the PyLiblo library, SSC based library. It's a bit more performative than the pure Python library, but I haven't compiled it yet for Linux. We also can switch on Python tooltips, and here a hint for the Control-Alt-Shift-C shortcut, which allows us to copy full data path to clipboard, which is very handy when you want to use your own open sound control message handlers. So when I go up here, you see here the three panels. We have the server panel, the node message panel, and the custom message panel. We're going to focus today in this part 1 only on the OSC server and the custom messages. Now when you press start, you will see how this OSC server is going to start up. You can stop, it stops again. Over here you can quickly toggle on PyLiblo library if it's available to you, depending on the operating system you're running Blender on. This here is the input IP. This is the IP of this machine Blender is running on. So this is your local IP. And the port OSC server is listening for OSC messages. If you want to communicate with Blender or NodeOSC server from another device than this one here, you would have to enter here a different IP. And you would have to enter your network IP, which would be something like this in my case. So I'm just quickly copy and paste this IP over here. And now every device that is inside the same wireless LAN is able to communicate to this machine through this IP and this port. If I want to send out messages to another machine than the one Blender is running locally, I would do the same thing. I would have to enter here the IP of the machine I want to send the information. The input rate says how fast NodeOSC tries to update the incoming open sound control messages. 0 means as fast as possible. The output rate, how fast NodeOSC will pull Blender properties to be sent out as OSC messages. Started launch is what it says. When you are running NodeOSC server, you have here a monitoring toggle, which allows you to see how fast everything is being updated by the add-on. And in case you're running with a pure Python server, you also get not handled OSC messages. So a message that is not met yet will be displayed here. Use this feature so sparingly, it's quite resource-hungry. With this, I'm stopping it, and I'm going to start to create the first message handler. The message handler is the collection of properties that allows you to tell Blender or the add-on how to deal with incoming and outgoing OSC messages. We have here first the direction. You can choose between input, output, and both directions. You've got the OSC address, you've got the argument indexes, the data path, and the property you want to change. Now, in our case, we want to communicate with something, and for the purpose of this tutorial, I'm going to use MaxMSP. So MaxMSP is another node-based application which allows me to very quickly set up those OSC messages. So what I can do now, I have here my cube, which is this cube here, and the location. If I hover over it, you can see now the full data path. And if I start the server, I should now be able to control the cube with the help of NodeOSC over here. So you can see now this little patch is generating the OSC message with address and the attributes, and they are being applied to the location over here. We can add another handler, for example, for the purpose of visibility. I create a new address, viewVisible. In our case, the property would be hide viewport. So I'm changing the property name, and now I should be able to control it, but it's not going to happen because, as it says here, we start server to apply changes. So I have to stop the server, start the server again, and now it's working. Now in terms of direction, I can also say it should be both. So it's sending data in and out, not happening again. So I have to stop and restart. And now I can see I'm not only controlling the data inside Blender, but I also get the data from Blender back. Because MaxMSP is listening on port 2009 and NodeOSC is sending it to the local IP, so in the same IP as MaxMSP is listening to. And last but not least, I'm creating a last handler. Let's call it tracking. And with this one here, I would like to, for example, control this property over here, which is the track axis property. I can enter this value, stop, and start the server again. Track axis, and so what I have here is a message. I'm see this is plus X, so I'm assuming I'm going to send, it's a possible solution, plus Y. I'm sending plus Y. Not much is happening here. I'm switching on monitoring and have a look what's happening. Down here we see there's an error message. Message attribute invalid, and plus Y not found in positive X. Here we see it expects the value in a different format. It has to be pos_y. So what I can do is I'm going to rename it. So it's a string pos_y. So if I'm going to send it pos_y, you see now it has changed. See if I'm going to send pos_x. Pos_x yes, pos_y, pos_x, pos_y, pos_x. So I can change that. Obviously I can try and see if it's going to work. But I can see now it's also sending me the information back. Now, last but not least, I mentioned the argument indexes, and this actually allows me to control which of those attributes I want to use. So if I'm entering here just 0, 0, 0, stop, stop, and I'm making changes here, we see here it's using the X value for all of the location values for X, Y, and Z. So this way I actually can control how the arguments are being used. Depending on how your OSC message is structured, this can be quite handy. With this, I'm ending the part 1 of the NodeOSC tutorial. I hope I will be able to give you more information in the second and third part.